Okay, so today this is a talk about NQL for Analytics, which is an implementation that's consistent with SQL++, and it is a tutorial for SQL users. So early in the session, I think Peter asked who had done SQL before in his life, and I think basically more or less all hands went up. So I think that this is true. If you are already familiar with NQL as well, with NQL for the query service, then of course there might be not too many really new things in here because they're both kind of NQL, and so you will see a lot of familiarity. So that is not a bug, that's a feature. So, but it might be a little bit less interesting at that point. Okay, so the agenda. We'll talk a little bit about the data model just in the beginning because we assume that you all know SQL, so we assume that everything's flat. We'll talk about that a little bit. We'll talk about the similarities with SQL, and then we'll talk about a few differences that you might find interesting if you're moving from SQL to NQL for Analytics. So, and the topics will be about, we'll get to that. That's select value, that's a statement kind, nested data, grouping and aggregation is interesting, and missing information as well. All right. Let's get started. Talking about the data model. So everything that we do in here will be based on the data that you see here. So these are basically we have some very interesting data sets. It's a customers and an orders data set. And so there are two things in here that I would like to point out in case you are a SQL person and you're used to flat data. So is there, I should know that, right? I don't know. Okay, so here on the left, you see on the first customer record there is this address field, and well, the address field contains an object, and an object is nested data, and as you know, in a relational database, you can't do that. So that's the one thing that is kind of special what we have here. And the other thing, the other field that I would like to talk about briefly is the zip code. And here up here in the first address, you see a zip code. Oops. And in the second, you don't. Right, which is another interesting difference between the data models, that you actually can have missing data, so data that is actually not there. Right, there is still the concept of null. It exists also in JSON, but here's an additional concept of data that is just not there because the whole field is missing. So these are kind of two differences, and the other one is also on there on the orders. If you see the blue field, that is the items field, which is also a nested data structure, which is an array. So we have two different kinds of nested data structures, which are arrays and objects here. So sorry. All right, so that's kind of what this data looks like. Of course, if you come from relational world, you could also model this as a relational model. So the customers, basically what I did to the customers here, that I took the object and just basically created fields, indented fields, because that was possible without conflict. So that makes it kind of flat. Of course, then when I have a missing zip code down here, now I need to put a null in because I can't just miss fields in a relational model. I did the same over there for the ship date, but the more interesting thing is that I also had to separate the orders and the line items, right? Because I had the nested line items in the order. And now I had to separate them out and basically normalize that to get to a relational schema. Right, and so that's the way it looks. Now I have one data set more for the line items that contains the orders that go with the line items that go with the orders that I have over here. This is basically stuff that I can just do in a relational system, right? I mean, in a relational system, what I would do is I would create a table that has the equivalent fields here, and I would tell you, okay, if there's an order number, line item number, a quantity, and a price. The one thing that's different here, so I have all of those fields in the JSON model as well, but of course I don't have types. So the types are part of my data, and they are not declared up front, so in principle I have more flexibility there. And the other thing that's also kind of related to that is that I declare nullability here in the relational world, and also over here I don't declare that. It's just like the types, I don't have to declare them. So now there's one little thing that I would like to talk about, what's also different. So I had this wonderful schema, and that was the same as over there, and now I'm evolving my system, and I'm adding a currency to the price of my line items. And well, basically I had a very easy mapping up front. Now basically all of a sudden I have this relation schema, and it doesn't fit anymore. So if I were to want to do such a change in a relational world, I would need to change that as well, right? And that's kind of one of the points that we're making that we don't need to do here. So that's just kind of a short example of that. All right, then there's another thing. This is what we would call sloppy data. So far, basically, I talked about variability in the data, which usually has a good reason, right? I mean, if I nest the line items in an order, there's a good reason for that, because that's kind of how the entities are structured. But of course, I can also do other things, like I see the rating here, and in the first customer, the rating is 750, and that's an integer, and in the second, the rating is 625, and it's a string. Now, basically, I have the same field in different objects, but they have different types, so that is possible and feasible, but not necessarily desirable, right? I mean, that's not kind of probably a good way to model your database, even though it's completely feasible in this data model. And I have the same thing over here on the right side, where I also, now I have a price, right? And the price all of a sudden is not a number anymore, it's a string. If you don't ask, it's too expensive or something like that. So these are the things I can do. And the other difference that I did over here is that instead of having, if I have a single item in an order, right, then I just put an object in there, and here put an array. These are all things where basically I can kind of create, friction, I would say, in the data model that is, not helpful, but still feasible, because nobody protects me against that. We'll talk a little bit more about that later. All right, so I promised we'll talk about the steps from SQL. So let's start at SQL and about the things that are the same. So there are just a few queries that are just like SQL. So you see this query, you probably know what it means. So I want to get the name of all the customers that have a rating greater than 650. And OK, so that will do exactly what you expect it to be. So I get this output. In our case, these are all, of course, relationally, those are records. In our case, those are objects with a name and a value, because there's a single field. So that's what I'm getting here. Another similar query, also very simple SQL. I get the name and the order date from my customers and orders, and I join them on the customer ID, and I just want to get this for customer 41, because that's the one I like. And so, of course, I get basically 2 orders from the same customer, all very simple and nice and SQL-ish. In addition to the syntax that you see here, the comma-based join syntax, we, of course, also support the join syntax that supports left outer join and inner joins, and which also is the join syntax that you would use in Nickel for query. Yet another query, because, OK, so we do analytics, so we need to have at least one thing that has a group by in here, and an aggregation. So that's also a very simple query. We get the order date, and we get the number of orders in that order date, and we have a having clause, and we can order this, and we get a nice syntactic, nice relational result. All right, OK, so now this all look good, but of course there are some caveats here. So if you look at this query, this also looks like a perfectly fine and nice SQL query, and if I run this, then it complains. It tells me, oh, you have ambiguous alias reference for the identifier rating in line 4 at column 7. So down there in the where clause, I have this ambiguity. And well, the problem is the following. So we are in the NoSQL world. We don't have a schema. So we really don't know what object or what record the rating field is supposed to be from, right? Because we have 2 records in scope. We have the customer record, and we have an orders record in scope. And we just give a field name. And nobody will tell us which field that is from, and therefore this reference is ambiguous, right? If I had a schema for my customers and orders, and I would know that customers has a rating and orders doesn't, then the database is able to resolve that. But in this case, since we don't have a schema, it doesn't. So the simple resolution to that is to do what you would do as a careful query author anyway. You would define aliases for these, right? And then you can precisely specify, you say from customers as C and orders as O, and then you get the name from the C variable and the order date from the O variable, and life is good, and you get a reasonable result. OK, now, another interesting point, select star. So when you use select star, then I think the way you usually use select star is if you want to find out what's in your data, right? You look at a table, you say select star, maybe with a limit, and you get the first 3 records, and you say, oh, OK, so that's about it. In a relation database, you could also get the schema of the table to kind of find out what's in there. But again, we don't have schema, so that doesn't work. So since this is really an exploratory use case, the select star actually looks quite different from what it does in a relational system. So the result of select star would be this. So what you're seeing here is that you get for each of those customer and order pairs that we're returning, you get an object that basically gives you those two variables, the C variable and the O variable that I have defined in this query, right? And it gives you the value of these two variables in a nested object, right? This basically ensures that you don't have any name collisions because you didn't have any name collisions in your aliases over here. And so you have no name collisions in that object. And you can get basically a view of all the data that you have in that data set, or what makes up the result of this query. All right. So this is kind of was the first set of what looks like SQL, some things that are a little different from SQL. Let's talk about things that are additions to SQL. So there is the select value statement. So basically, we had a select statement before. And maybe I even go back quickly. Sorry. That makes it confusing, huh? So the top thing that I had here, right? The result was, as you can see, there's an array. And inside of the array, we have records. And they have a single field with a name. So now, but if I just want to have the names, not the record around it, right, then that's exactly what I can do with the select value statement. So here I have select value name instead. And so what that will do, it will only give me the value of that field, right, without a record constructed around it. So the result of this basically is I don't have those records. I just basically have an array now. Those are the three strings of the values that allows me to extract the values from that record. I can also do something else with it, which is very interesting. So in addition to the ability to just extract the value, I can also use this to apply other expressions on my data. In this case, what I have here is an object constructor. So I construct a new object, a new record, with this constructor. That's the kind of the curly braces after the value. And what I do here is I construct this value with a field that's called customer name. And the value is c.name, and there's the field called order date, and the value is o.order date. And I construct a record out of that, and the result of that is what you'd expect. It's again a nice record, but this time basically I've explicitly created this record. And in principle, I could also have the names be expressions that are evaluated. So in this case, those are both constants. And in the case that those are both constants, this is actually exactly the same as giving these fields as aliases, right? I mean, on the right side, I kind of have a SQL formulation of that, where I give the names that I've chosen for the fields on the left side as aliases in the select clause. And so that kind of a select clause is equivalent to this object constructor. Yep. All right, and then there's another interesting thing that I can do in here. So now I can also nest this, right? And I can construct these nested objects, another good use of the object constructor. Here I construct now an object that has the customer name, and it has all the order numbers for this customer. So you see the nested query in here in the orders field is select value, so that the value that gives me just the number from orders, and then with a join predicate in here. Okay, and that will yield the result that you expect, right? So what you see here is you get the orders, and the orders, basically the result of a subquery is always an array, right? And you get this wonderfully nice object, and you have constructed that easily with Nickel for Analytics. Okay, now, you've all listened, right? And it was all very interesting, and now we do a little quiz. So we want to have a query that retrieves the names of the customers that have the highest rating. Okay, now, and I have 4 proposals for you. What those queries could be, you can see them on the right side. I think you can all read them, so maybe I don't spell them out. And so, yes. So maybe we can do a show of hands. Who thinks that A is the correct answer? Nobody? Okay, good. Who thinks that B is the correct answer? So, good. Who thinks that C is the correct answer? Okay, nobody. And who thinks that D is the correct answer? Don doesn't count. Yes. All right. So yes, I think we found the correct answer by quorum and a lot of abstaining votes. So let me explain why that is the case. So the first kind of approach to this is formulate this similar to what you would do in SQL, right? And if you try to run this query, this will be the result. It will tell you that there's a type mismatch and the expected value of type multiset array, that we expected value of type multiset of array, which is basically the two kind of collection types that we have, but instead we got an object, line 4, column 28. So that is the customers that we see up there. It's complaining about that. So it tells us, I want a collection in the from clause, but you gave me an object. And the reason for that is, if you look at what I did up here, I select from customer. So basically in the following query, the variable for that iteration variable on the customer's data set is bound to a single record. And so then basically that binding is resolved there, and then I have an object there, right? And well, the error message is correct. That will be tricky. Okay, so again, the solution is relatively simple. I introduce a nice iteration variable that resolves my problem, and I have two different iterations variables to iterate over the customers, and now basically the query does what it's supposed to do. Well, not quite, right? I mean, it works, we have no error anymore, but it gives me an empty sequence. So, did I just say empty sequence? I'm sorry, that's, yes, my X-query is showing. Okay, I'm sorry, so it gives me an empty array. All right, so one of the problems here is that if you look at this query, this says select max of so. I know that the select clause always returns an object, right? So, and if I compare this object with a rating, which is just a scalar value, of course, it won't agree, and so I get no results, as I have earned. Okay, so then I say, okay, that's fine. So now let's get a single value, use select value for that, right? That's the way to get a single value. So I have the same query as above, but now I introduce select value here, and now I want to see, okay, does this query work? And the result again is, well, not quite, because I still know that the subquery that I have in here, right, that returns an array. So now I'm comparing a single value to an array, and that again doesn't work. So the next thing that I really need to do to make it work is, as some of you have said, right, make sure that I get the first element of that array, which actually is a scalar value that then compares with the scalar value that I have from C1, and I get a sensible result. All right, so this is an interesting caveat in general, right? Because one of the things that the language does, that DICL does in general, it's a schemaless language. It's very forgiving. Often, basically, if something cannot be done, it returns to you null. And if you have a comparison net, it's false. So you won't get an error message. So looking at, oh, I got an empty query result is not an uncommon thing when you're debugging a query, right? You don't get many errors. It's just you get, yes, and you have tried it. All right, so as I said, so you already got the right answer, so here's the confirmation. Okay, so now let's talk a little about nested data. So we said we have nested data. And so of course, one thing you want to do is if you have nested data, you want to unnest it to run queries on it. This is the way this looks. So you can see here, we in the from clause, you see we from orders as O, and then we have the unnest keyword O.items as I. So which basically what this does is, so O.items is an array. And what we'll do with the unnest clause, we will unnest that array. So basically now I get pairs from the from clause of orders and the individual items, right? I will unnest that array, and so then I will get those order item pairs. And then I have a condition on my items, then I order them, and the result looks like this, right? Now this is all nice and flattened. Got the order node, order date, then the item number, and you will see that basically, well, no, look at that. My order by didn't keep my orders together, but oh well. But I get these orders and the order dates and the item number, it's all flattened. An alternate way to do that instead of having the unnest keyword is that I can just also use a comma here. So basically that's one of the features of the language is that you get an implicit left correlation when you basically list your sequences in the from clause separated by a comma. So you have an implicit left correlation here, which means that the O that you have bound on the left is the same O that you get on the right. So basically then on the right, for each O that you have on the left, you get this array and you unnest that. So that's a little bit shorter way of writing that down. Okay, then on quantification. So what you do is if you deal with these nested structures, with nested arrays, right, you sometimes want to kind of find out if something is true for the whole set of values that you have, right? And you know that in mathematics, right, you have the universal quantification and the extensional quantification, and in this case, that's kind of the same thing. So what this basically tells me is I will take my orders, then I can have this in the where clause. I have where sum I in o.item satisfies I.price is greater than 25, which basically means that this predicate is true if there is at least one item I in this array of items where the price is greater than 25. So if I have at least one expensive item, right, then this predicate is true. And so basically in that case, I will get the customer ID of that order. And so, okay, it's not a hugely interesting result, but you will get the customer IDs of all the customers that had at least one order, that had at least one item in the order that was greater than 25. All right, so now that was the case that, okay, there's at least one. So the next case, of course, that we need to look at, so if we want to say something about all of them, right? So then we have a very similar formulation. So instead of having the sum, we have the every keyword here. So here is the condition is where every item in the item satisfies that the price is greater than 25. So naturally, we'll probably have fewer results of that, which is true. So there were at least two items that had one item above 25, but not all of them. All right, and then of course there's an interesting corner case that you should consider. So the condition every I in O items satisfies I.price greater than 25 is trivially true if there is no item in that array, right? If there's an empty array, then I say for every item in nothing. So for everything in nothing, we just say, yeah, that's true, right? So everything that's there, there's nothing there, so there's nothing to say about it, so that's trivially true. So if you run into that problem, right, that's also a common problem that you could run into. Basically, you need to also make sure that your array is actually not empty. If that's the case, you want to protect yourself against, and that you can do with something like this, where you have you get the size of the array, and if it's greater than 0, then actually you want to have this, and if it's 0, well, it cannot be less than 0, then yeah, it shouldn't qualify. Okay, yes, sorry. The result is the same as before because there was no empty array in there. Okay, and of course, it becomes really interesting once you kind of have this nice composable language and you can compose these constructs, right? In this case, what we did here is we want to have the whole customer for each customer there where for each customer whose customer ID is in the list that I've selected in this way. Basically, I went through all of my orders. I found the customers with expensive orders. So far, I only had customer IDs, but I really would like to have the whole customer for that. So basically, I can nicely compose that, putting the extensional quantification inside of a subquery and using that in my in predicate in the outer from class here. And then I get my results that contain the whole customer objects. All right. So maybe intermediately some other questions on.
I'm sure that the informal query doesn't include the look through the whole customers again for every customer.
Yeah. So basically, I mean, that is we have a query optimizer and we analyze that, right? And oh, yes. So the question was basically, do we know that we don't run through the whole data set again and again, over and over again, right? So basically, What we do is as in a database system, we have different join algorithms, right? And basically, in this case, we would rewrite this query into a join.
Does it show on explain?
On explain, you would see the join method, yes. Basically, there is a join method, right? I mean, it will be rewritten. You will see the rewritten plan, right? And the plan will basically not have necessarily the same structure as the query is written, right? But it will basically be the execution plan that the optimizer has determined to be the right plan. And in that plan, you would see that. And you would also see if for some reason the...
Always true and always possible. If you have an internal query,
Yes.
that is no condition.
Yes, no, if it's not possible, yeah. I mean, I think, okay, I'm getting one step back. So there is an optimizer, right? The optimizer tries to rewrite this, right? And basically, it tries to do the analysis, and it tries to rewrite the query in a way that it can be efficiently executed, right? Without doing that. And using different join algorithms, right? Using hash joins or index joins. But, sometimes you cannot, right? And then you get a nested loop join, and then the plan will tell you, you know what?
They're asking for it.
Yes.
I could see
Yes, you can, yes.
if it was successful optimization or not successful.
Yes, you can look at the plan, and the plan will basically give you the operators that you have in the plan and the join methods, and you will be able to see that. Yes. Yes.
Are these samples available after the presentation? Do you have a link that we can refer to?
Yes, but even better, I think you should have gotten a book. And most of these things are described in more detail in the book, so the book is way better than my slides. This is just kind of the short highlights, but the book is basically the data is the same as in the book, and so.
Data is online too, so
Yes.
get that and set it up.
All right. Next on, grouping and aggregation. So so we're doing analytics, so clearly grouping and aggregation is important, right? That's what the business of grouping and aggregation is. This is a very regular grouping and aggregation query. You join customers with orders, you group by the city, and then you select the city from that, and you want to know how many customers do you have in that city, and the result of that is, okay, so we have 2 in Boston and 6 in St. Louis, okay? Very simple query. So this works, and it's all nice, and I think we're all used to that, but it's actually kind of hard to explain this within the relational model, right? Because if you know, in SQL, grouping only goes with aggregation, right? You can only do aggregation together with grouping, and you cannot kind of separate the two, right? Because there is no if you want to explain this, right, then usually what you do, I mean, I have a university teacher here who tries to explain that from time to time. You introduce an intermediate construct that looks something like this, right, which has these groups here, and we have these groups of objects, and then you have here two customer order pairs for Boston and 6 for St. Louis, Missouri, and those are 2 and 6. And basically, with such an intermediate construct, you can explain this, but it's not within the relational data model, right? Now, we are luckily, right, in a non-relational data model, and so we actually have nesting, and so we actually have a way to kind of have a better explanation for what is happening here that doesn't have to leave the data model of the language we're actually in. But before we come to that, let's just take half a step back, which is, so in C++ or Nickel for analytics, you can actually separate aggregation from grouping, and you can do aggregation only, and you can do grouping only. So that works, so you don't have to put these things together. So we have a very simple case here that's actually very unproblematic. In this case, we take our customers in orders, and we join them. And for the orders, we want to know how many items we have in the order. And so we use this array count function on a field in a record, right? Which is, yes, it's aggregating, but it's not aggregating across tuples. It's just aggregating over a field within a single record, right? Not a big surprise that will work, but it's a simple way of kind of aggregating that and describing what's happening here is you put an array in, you get a number out, it's a function. What else do you expect? And the result is something like this. All right. Now, if you look at this from a SQL perspective, you do select value at this of the max rating from customers, and I think we all have an idea from SQL what this means, right? Which means you want to have the maximum value for customers. But what I just said, that you basically you put something in and into the function and you get something out. You just put a collection and get a function out. It's not true here, right? There is some magic happening here which tells me that actually what I'm doing is I'm taking the customers, I'm walking over the customers, I'm getting the rating field, and I aggregate over that. So it's not like I can't see that collection, right? It's just, I know that this is the way this works in SQL. So in kind of equivalent way that you could write this in NQL for Analytics, oh, first, okay, sorry, I have the result, sorry. Forgot about the result. You could write it like this, right? So this would be kind of an equivalent formulation to do the same thing, which is more explicit than what I have in the SQL formulation, which is that I create the collection by selecting the value rating from customers. I have this collection, now I have a nice array, and I get the array max function on top of that, and basically getting the maximum from that from an existing collection, right? That's, again, kind of what I had in the first case, which is sequence goes in, value goes out. It's a function call, as you would expect. So that is kind of a way that you can think about aggregation here and be more explicit about what it actually does. All right, same result. OK, so now another interesting aspect is that you also can only do grouping. So you can have nested data, right? And so therefore, you can actually represent a group. You can represent a group of things. And the way you can make that visible in SQL++ is with the group as clause. So what you can do is that you can give a name to those groups and then actually see the groups that are constructed in this clause in your query result. So in this case, let me show you the result. It's a little bit bigger. OK. So what I'm doing is I'm joining the customers and the orders again on the customer ID, and then I group by the city, and then here I will see the groups. And what you will see here is that for each group, you first have the purple color, you have the grouping key, right? And then you have this variable g, which contains an array of all the value of all the pairs of customers and orders that I had. Right? These make up the group. So the first group that we have has the grouping, what is it called? Yes, the grouping value is the grouping value Boston. And then for that, I have the group. And the group consists of two different, basically an array of length 2, which has two objects that each contain a customer and order. Right? I have the red customers here and the green orders there. And that is basically the whole description of the group. And you basically, this is an instance of the data model, and you can run whatever other queries you would want to do on top of this. Right? This is just a new instance in the data model, and you're free to do whatever you wanted there. And kind of with this tool, right, or with this ability to express this, you can also have a nice explanation on how grouping and aggregation actually works. So if you look again at this query that we had in the beginning, which was the SQL formulation, if you kind of would write that very explicitly in NQL for Analytics, you would just introduce the grouping variable, right? And then count the elements of the grouping variable. And that is exactly the size of the group, right? And that is, again, there you have a function that, the collection goes in, the result goes out. It's very, very natural and functional in nature. Does that make sense? Questions? If you're nodding, that's good. All right. All right. The hard part is done. Now let's come a little bit back to missing information. So what we had at the beginning, we said, oh, we have this data model, and we can have missing information. And so that is something we need to deal with. And coming back to this data, right? I mean, we had the missing zip code here and the missing ship date there. And so, of course, it's in the data. We also need to be able to deal with it. And so to just talk a little bit about it, I have this this simple query that basically takes the orders, it selects all the records where the ship date is missing, and then I want to select from that the order number, the order date, and the missing ship date, and the customer ID. And if I run that, the result is kind of what I'd expect it to be, I guess, which is, okay, I get these records, and I selected 4 fields, I only get 3, right? I get the order number, the customer and the customer ID, and the ship date that was missing in the original object is also not in this result object. And if you think about basically what we said, what this construction of select actually is, where basically we have this implicit object construction. So I'm just breaking this down now and using a more explicit formulation of having this select value with the object constructor. This, I think, makes a little bit more sense at this point in time, because what you do is you see that, yes, we have the order number field, we give it the order number value, which has a value. We have the order date field, we give it the order date value, it has a value. Then we have the ship date, and we give it nothing, right? We give it a missing value, which basically in this case for the object constructor means we cancel the construction of this field. Right? That's kind of the mechanics of doing that. And then again, the customer ID works, and we'll get the same result. And okay, missing is one of those fields. It's an interesting one because it's new compared to the relational world. There are other ways of dealing with missing or unknown information. There is basically, of course, you can also say things like it's not missing. You can say it's unknown. It's unknown means it's either null or missing. So if you want to cover both cases, there is a simple keyword for that, or you can just talk about the fact that it's null. So there are different ways to go about it. If you want to know more about this and about kind of the interesting aspects of having this 4-valued logic between true, false, null, and missing, then you read the book, and it will explain in detail. All right, now just one simple example of, okay, so you have this missing information, but you don't like it, so of course you want to deal with it, and basically what you do is relatively simple. You can do things like this. You use the case statement that you know from SQL, right? And in this case, all I want to do is when the ship date is missing, then I replace it with a string TBD. And otherwise, I'll just get the ship date. So this is kind of, the case statement is one of those that help you to deal with with the structure of the data, right? I mean, it helps you potentially with your sloppy data as well. But if you don't have that much sloppy data, even these cases, you might just use this for presentation or whatever you do. Oh, look at that. Actually, I have an example result. All right, next steps. Actually, there's only one next step. It is read the book. It's really good. It's really interesting, and I think you got it, every one of you. So with that, I'm done. Thank you very much.